this video, we will discuss how we can create an objective function for any real life problem. So if you are working on any project and trying to solve any real life problem, by following simple steps, you can create your own objective function. And in this video, we will consider this real life example and we will create an objective function for this problem. So now we will follow certain steps to create an objective function for any real life problem. Step 1, define the problem. Here we will identify the goal. So clearly state what you are trying to achieve. You're doing maximization or minimization. For example, we can maximize profit, minimize cost, improve efficiency. According to different problems, we have different objectives. So first you will identify what is our goal, what we want to achieve. After that, we will understand the constraints. In previous videos, we already discussed what is optimization, different types of optimization problems, design variables, objective function, constraints. So if you are new to these topics, you can check these videos. So next we will understand the constraints for that problem. So constraint is like any restriction or limitation. So we will identify any limitation or restriction within which you need to operate. Step 2, identify variables. In step 2, we will determine the decision variables. For example, in production problem, decision variables could be quantities of different products to produce. In step 3, we will formulate the objective function. We will express our goal mathematically. So in step 3, we will mathematically represent the goal that we want to achieve. In step 4, we will include the constraints. So identify the constraints like the conditions that must be satisfied. So constraints could be resource limitations, time restrictions, budget limits according to problems. So once you identify the constraints, mathematically represent the constraints. After that, in step 5, verify and validate. We will check the formulation. We will ensure that the objective function and the constraints accurately represent the real life problem or not. We can test with sample data. We can use any sample data to test the objective function and constraint to see if they produce the feasible solution or not. Now we will take a simple example and we will create an objective function for this real life problem. So imagine this person run a small bakery and he need to purchase flour and sugar, and he need to produce a certain number of cakes, pastries and bread each day, and based on their recipes and production schedule, this person need at least 80 kilograms of flour and 50 kilograms of sugar each week to make the demand. So here we have the minimum requirements. So we have this simple example. This person need to purchase flour and sugar, and this person has specific budget that is $100 and specific requirement for each ingredient like at least 80 kg flour and 50 kg sugar. So goal is clear. We want to minimize the total cost. Now we will identify the constraints. So constraints are the restrictions done. So here we have first constraint, we have here budget, that is $100, and then we have the minimum requirement, that is we have specific requirement for each ingredient, like here we have minimum requirements for the sugar and flour. In step 2, we will identify the decision variables. So we are taking here x, that is the amount of flour in kilograms, y, that is the amount of sugar in kilograms. So we have two decision variables, x and y. Now in step 3, we will formulate the objective function and constraint. So here we will mathematically represent the objective function and constraints. So first we will formulate the objective function. So suppose the cost per kilogram of flour is $0.50 and the cost per kilogram of sugar is $0.75. This is our objective function. We will minimize the cost, that is equal to 0.50x plus 0.75y. Done. Now we will add the constraints. So here we created the objective function. Now we will add the constraint. So here we have the budget. So suppose we have this person budget that is $100, and we need at least 80 kilograms of flour and 50 kilograms of sugar. So here we have first constraint, that is the budget constraint. We have first constraint, that is the budget constraint, 0.50x plus 0.75y, and the value for this would be less than or equal to 100. This means that the total cost of purchasing flour and sugar must not exceed $100, because we have budget $100, so the value should not exceed 100. Next constraint, we have minimum flour requirement. That is, so x we are using here to denote the amount of flour in kilograms. So x value should be either greater than or equal to 80. That is, the bakery need at least 80 kilograms of flour. Third constraint, we have minimum sugar requirement. So this is denoted with y, that is the amount of sugar in kilograms. So the bakery need at least 50 kilograms of sugar. So y value should be either greater or equal to 50. So now you can see we have the objective function and the constraints. Now step 5, we will perform validation and verification. So now we will solve the constraint and check if the minimum required amount of flour and sugar meet the budget constraint or not. So first we will calculate the cost if we just meet the minimum requirements or not. So here we are taking the value for x 80, y that is 50. Now we will calculate the cost. Put x and y value in the objective function. Here we will put the value and see the cost is calculated here, that is 77.50. So now we will verify the budget constraint. So here you can see 77.50, it is less than 100. So since the total cost of $77.50 is within the budget of $100, so the minimum requirements are satisfied. Therefore, this optimal solution minimizes the total cost while satisfying all constraint by taking value of x 80, y 50. So final result you can see here. Amount of sugar that we will purchase 50 kilogram. The total cost we got here $77.50. So this solution ensures that the bakery meets its minimum requirement for flour and sugar while staying within the budget, and it minimizes the total cost of purchasing these ingredients. Now here you can see the graphical representation of the feasible region and the optimal solution for the bakery. Here you can see on the x-axis we have the kilograms of flour, on the y-axis we have the kilograms of sugar. This blue line represents the budget constraint. Green dashed line, it represents the minimum sugar requirement. Red dashed line, it represents the minimum flour requirement. After that, you can see this red dot, that is the optimal solution. It represents the optimal solution where the bakery should purchase 80 kilograms of flour and the 50 kilograms of sugar. So this combination minimizes the total cost while satisfying all constraints. So in this example, we learned how we can create and solve an objective function for a real life problem using linear programming. So you can also do this by defining the problem, identify the decision variables, formulate the objective function, and then add constraints, and then we are able to find the optimal solution. So for this bakery example, we aim to minimize the cost of purchasing flour and sugar while meeting the bakery needs and staying in a budget. So we found that purchasing 80 kilograms of flour and 50 kilograms of sugar at total cost of $77.50 satisfies all constraints and minimize the total cost. So by following these steps, you can create objective functions to optimize various real life problems. You can minimize cost, maximize efficiency, optimize routes. So by following these steps, you can solve any real life problem. So that's all about this video. If you have any questions, you can comment below, and thanks for watching this video.